All right. Hey guys, welcome back to another Math 9B video. So today I'm going to be talking about differential equations and initial value problems. On the blackboard, you can see I've already abbreviated them, diff EQs and IVPs, right? So right off the bat, we can notice that there isn't a lot of difference between the two types of equations. They're basically the same equation, right? But in order to understand IVPs, we kind of have to understand differential equations first. So the goal of any differential equation is to get f of x, right? We want to get back to f of x. If we're given a derivative, right? I've used here the general notation for derivatives, right? So if I'm given a derivative equation, I want to be able to get back to f of x, right? And so if you guys remember the from last video, how we get back to f of x is we have to integrate, right? So the steps for solving a differential equation are is basically just one step, and you kind of just integrate until you get f of x, right? So you're going to just keep integrating until you get f of x, and you have to you can't just do like 3 intervals at once. You have to go like step by step, right? So you keep integrating until you get f of x, right? But notice here how every time, if you guys remember, every time we integrate, we end up with some unknown constant, right? And we kind of just leave it there because there's no way that we can actually solve for that unknown constant if we just have a differential equation, right? So note here that we're going to get what we call a general solution, right? So this general solution is going to be something that looks like you're going to have, right, you solve for f of x, you're going to have f of x, it's going to equal like some function, right? And then you're going to have a plus c, right? And so this plus c is what makes it a general solution, right? So when we do IVPs, IVPs are a specific type of differential equation where we are given these things on the end right here. These are called our initial conditions, right? So our initial conditions are what we use to help us solve for this plus c in our general solution. So when we solve an IVP, our steps, first we have to solve for the general solution, right? So the way that we solve for the general solution is we have to solve the differential equation. So basically we have to first integrate until we get f of x, just like we do for a differential equation, right? So this is going to give us our general solution. And so once we have our general solution, what we can do is we can use these initial conditions to plug in to our general solution so that we can find our values for C, right? So our second step will be to plug in initial conditions, right? So after we plug in these initial conditions, we're going to get our specific solution, right? And so that's kind of like the real thing, the real difference that sets a differential equation and an IVP apart, right? Differential equation, you're just going to get some general solution. There's going to be some plus c in there. With an IVP, we specifically are working to we're specifically working towards a specific solution, right? We don't want a plus c. We want to know exactly what our function is, right? And so we need to be given these initial conditions, all right? Another thing that I wanted to know is if you are integrating multiple times, right? So down here, I have an example. I've already worked out the example, but I have an example of a double derivative differential equation, right? So notice to solve my double derivative differential equation, what I do is I have to integrate twice, right? I have two derivatives, so I have to integrate 2 times. The first time I integrate, right, I'm going to get this thing right here. Notice I have the C1, right? When I integrate a second time, I have to integrate the whole thing, right? C1 included. So when I integrate the C1, or when I integrate this whole thing again, I'm gonna have that this C1 becomes a coefficient, right? And then I have to add on this other C2, right? This other constant that I got when I integrated a second time, right? So basically, my point here is that when you solve a double derivative differential equation, you can't just integrate twice and then just throw in two arbitrary constants at the end. One of your equations might, or one of your integrals might depend on that first constant, so you can't just kind of like make two and throw them at the end, right? So that's just a little warning. So yeah, that's all I have for this video. If you guys have any more questions or you want to talk more about it, feel free to come see me during my office hours. They'll be in the description box below. But I hope you learned something from this video. Thank you for watching.